Yeah, so I think we're at 6:05. So I just want to start off by acknowledging that many members of this meeting are attending from the unceded ancestral, traditional territory of the Musqueam and Coast Salish people. Me, this institution, and this team have benefited from a brutal colonial legacy, and we as aspiring engineers strive to make the world a better place, and to do that, I think context like this is vital. So to begin with that, now I kind of want to move on to welcoming you all to the Best Info Nights. And so what we're going to be doing today is we're just going to be taking a bit of time to run through what our team actually is, and give a sort of breakdown of the structure and sort of what opportunities exist within our team. We can talk sort of in a bit more depth about each of the projects. So we'll have representatives from each of our project teams coming in and giving you a rundown. And of course, you would have seen the relevant postings on our websites. And then we're also going to talk a bit about our mentorship program, which is our opportunity for first-year engineering students.
Awesome, thank you. So just sort of a brief overview of the evening, which Alistair just gave. And here you can see the teams. This is a photo from the last time we were allowed in person together earlier first semester of last year. And just an overview, we're a multidisciplinary team of about 90 members, and we focus on developing context-appropriate solutions to medical challenges in our local communities and also all around the world. So we have involvements with industry and with research teams, as well as certain competition groups all over the world. And each of our specific teams will be able to speak a little bit more to that. By the numbers, we're just over 90 members normally, with 7 different project teams going at any given point in time. We cover at least 8 engineering disciplines and 6 different faculties at UBC. And every year we take around 10 mentees, and these are people who help with our teams, as well as attending technical and professional workshops that are run by the upper year students and the management at BEST. So in terms of where a BEST alumni or alumnus might end up, you could picture these people all over the place. And in fact, many of our alumni have ended up at larger companies like Google and Microsoft, biomedical companies like Cardium and Boston Scientific, Intuitive Surgical, which is known for the Da Vinci surgical robot, as well as Stryker, Amazon, IBM. So it's not all biomedical specific, but as you can see, some of the skills that our members have gained over their time on the team have benefited them in terms of really successful and exciting careers moving forward. So to kick us off, I believe, oh, just kidding. Here's a look at our leadership team. We've got 3 co-captains, and then we also have a mentorship lead and co-heads of mentorship and a sponsorship coordinator. And here's a look at a bunch of our team leads. Sabat Alessandro for Daniel, but more or less, these are the faces that you would see, or at least some of them if you ended up joining us every Saturday. Collaborations and clients, all over the place. So, these are places that are quite notable: Vancouver Coastal Health, as well as Open BCI, the Tetra Society of North America, which is a group of retired engineers for the most part who work to build assistive devices for people in need. The Center for Hip Health and Mobility, which is a very reputable research group, as well as UBC School of Biomedical Engineering, amongst many, many others. So I think we're going to kick it off by talking about our mentorship program. And if Jessica and Jackson wanted to take it away and unmute, I can pass it off to them.
Yeah, for sure. So hi, everyone. I'm Jessica, and my co-head of mentorship is Jackson, who is somewhere in the Zoom call.
Hi, everyone.
But basically, our mentorship program is specifically for first-year students to sort of help you gain the skills to feel like you can be actively involved in one of our sub-teams, as well as, teaching you about SolidWorks, coding, creating a better resume, cover letters, and things like that. So you'll have those workshops on top of joining a sub-team, on top of having mentorship from the different people within that sub-team, as well as both me and Jackson. So next slide. Merci beaucoup. So this is sort of an overview of what the mentorship program looks like. So applications for all of BEST are due on September 21st. And after that, you have an interview, you get to join your sub-team for best, and then at the end of the year, we'll have sort of a year-end presentation or competition. And then at the end of April, you will officially join your sub-team of choice. Next slide. Yeah, so there's sort of an overview of some of the workshops we're doing. Obviously, with COVID, it's a little difficult for us to get students in the lab to perform our chemical and biological workshops and things like that. So we're currently in the process of coming up with new workshops for you guys, and we're always open to suggestions and sort of ideas for things that you guys would think important for first year, but even after that, all the way until your end of your degree. So yeah, let me know if you have any questions about what the mentorship program kind of looks like and what you could expect.
Awesome, thank you, Jessica. And on to MAST. Daniel, you'll just need to unmute yourself, I think.
Okay, so we're primarily a software-based team, so our ongoing projects, or projects, I guess, is in collaboration with Vancouver General Hospital, particularly the radiology and emergency departments. So the one we've been working on for about the past year and a half or so has been an application that helps the radiologists connect with the first responders. Fortunately, I can't say too much more than that since we're under NDA to be unable to disclose any further details. So that one we actually presented earlier this week, and that's going to be getting ongoing support by the radiology department. And then we're also moving forward with another project, which is primarily to integrate some kind of ML image processing into their emergency room dashboards. So in terms of skills that we're looking for, primarily it's going to be modern front-end, full stack development in modern front-end frameworks, so React, React Native, and as well as any ML skills would be quite useful. And then what you also will be getting from this is being able to communicate directly with professional stakeholders right at the forefront of patient care.
Thanks so much, Daniel. Moving on, we have Mint.
Okay, hi everyone. I'm Han and I am the co-lead of Mint. Unfortunately, Caitlin cannot join us today, but yeah, I'll let you know about Mint. So we are multifaceted innovation in neurotechnology. So basically we explore affordable neuroscience and neurotechnology, especially their application, such as controlling a robot or a computer just using your brain waves. And we joined a neuro competition and hackathon, such as Neurotech X. And we would love to collaborate with researchers, engineers, neuroscientists, and neurohackers. And mainly that. Next slide, please. So this year, actually, the projects are the same as last year. We have two projects, the home automation using EEG and the EEG acquisition system that now we name it the jellyfish, mainly because of its shape. So the headset you see there is just representative. Ours is not as nice as that one yet. Yeah, but anyway, we have got the main design for both of these projects, but for sure we still need help from new members to help us really finish them by this November and join Neurotech X this year. And also the long-term goal is that we want this app and this headset can be used by own people, open source, and so that the neurotech world can have more data. And also, yeah, maybe one day all of us don't need to touch a button to control things anymore, just your brainwaves. Yeah, oh, and this year we are recruiting electrical members and app members. So even though you don't have that specific skills, if you have any related skills like machine learning or I don't know, mechanical skills, machine shop, manufacturing thing, yeah, then we're more than happy to have you on the team, especially your enthusiasm and want to learn. Yeah, that's that. Thanks.
Thanks so much, Han. Moving on, we have John from Enable.
Hi everyone, my name is John. I'm one of the co-leads for Enable. So we are a client-focused team, and we develop custom assistive technologies for individuals with disabilities. We primarily receive project referrals from the Tetris Society and Neil Squire Society. So I feel that this is a very cool team to be a part of, to see the full design process in action, right from the beginning, where we meet with clients and discuss their needs and design requirements, and then the whole process of design ideation, prototyping, and final product. So we're a highly integrated team. We have students in many different engineering disciplines. Because of this, we take on projects that are pretty integrated, and we usually have several projects on the go. So this team is excellent for someone who wants to broaden their technical skill sets in mechanical, electrical, or software design. And there's also opportunities in client consultation and developing project management skills. So we're not looking for any one type of engineer in particular, engineering students, just someone who wants to learn skills, and we'll collaborate together on finding projects that you'd like to work on.
Thanks so much, John. And onwards to Uplift.
Hi, everyone. My name is Rebecca, and I'm one of the co-leads for UBC Uplift. My co-lead, Danica, couldn't be here, but she sends her regards. So Uplift began last year, and we're projected to wrap up the project by the end of this school year. And our mission at Uplift is ultimately to help our client, who I'll tell you a little bit more about in a second, and to maximize the development of our members. So this project is being done in collaboration with the Neil Squire Society, so we're working closely with them to deliver a product to our clients. Next slide, please. Thank you. So our client's name is Nazleen. She's the sweetest lady you'll ever meet. So she had polio when she was a child, and she now suffers from post-polio syndrome, which has resulted in mobility challenges that require her to use 2 crutches and 2 braces to get around, as you can see in the pictures. She also has severe osteoporosis, and she's at high risk for muscle atrophy. And in January, her access to care aids will become limited. So some of the things they do around her house on a daily basis will become her responsibility. And given her condition, some of these tasks are exhausting, dangerous, or even impossible for her to perform independently. So our goal is to design a device to help her complete these tasks around her home. Next slide, please. So in the past year, we've been busy on all aspects of the design. We have a mechanical prototype that we're putting the finishing touches on, and electrical and software elements that are being developed and implemented. We're working towards assembling the full device and getting it to our client by the end of January 2021. So if you'd like to help us cross the finish line, we are hiring mechanical and electrical engineers. You can check out the Qualtrics form and role descriptions on the BEST website if you're interested. And you can also follow us on Instagram at uplift.ubc. If you have any questions, feel free to reach out at uplift.ubc@gmail.com. Thank you.
Thanks so much, Rebecca. Onwards, we have MS to movement.
Awesome, thanks. So hey, lovely folks, I'm Ahana, and I'm one of the co-leads for M2M with Tony, who unfortunately couldn't make it tonight with us. So our team is called MS to Movement, or more popularly as M2M. As the name probably suggests, we're working to make the rehabilitation process of multiple sclerosis (ESEA) more accessible and more data-driven. Approximately 1 in 3 85 Canadians suffer from MS and its grave, severe neurodegenerative consequences, which require routine rehabilitation process. Even though some methods do currently exist, a lot of them are more qualitative than they are quantitative and require access to a therapist. So our vision is to build a device that aids patients in gaining control over their therapy and that provides them access to this amazing, huge MS community. Next slide, please. So we are still in the early stages of our design, as we had to reiterate a couple of things. But here's a brief overview of what we've been thinking about in the past couple of months of summer. Our goal is to create an interactive app-based platform that allows patients to play games that will in turn help them gain control over the movements of the lower arm. So the design would have various sensors that would relay information via Bluetooth, which can then be stored and processed and then showed to the patients for them to analyze how their progress has been. So we're basically looking for, well, software engineers, so senior software developers who have certain app development experience and certain electrical engineers or people with electrical experience as well. So we're super stoked about the upcoming year and the progression of this project. I'll now hand it over to one of our amazing team members, Alana, who has been a mentee with us for a year and is now one of our key team members. And she'll take you through what we're currently working on.
All right. Next slide, please, Emma. Hi, everyone. I'm Alana, and I'm another M2M member. So we're currently working on UI UX design, app development, data storage, and circuit assembly and PCB design, as well as material assessment and interviews with patients and therapists are ongoing. And then next slide again, please. And then some organizations we're collaborating with are Vancouver Coastal Health and Neuromotion Physiotherapy. So, yeah, thank you.
Fantastic. And next up, I believe, is Rana with BIT.
Hi everyone, my name is Rana. I am co-lead of BIT along with Novia. So BIT is the biochemical innovation team at BEST. Slide please. Okay, so we have a PC project, which is pre-COVID project, and we have the project we're currently working on. Our PC project was determining the effect of extracted cinnamon polyphenols on glucose uptake, which is a project kind of looking at diabetes type 2. I was looking at extracting these compounds called polyphenols from cinnamon and using them to look at the effect of glucose uptake in pre-diabetic adipocytes, which is a type of cell. And we were kind of at the peak of our project until COVID happened. Yeah. So now that COVID is a thing, we decided to move to a remote project. So the project we're currently working on is a coronary heart disease project. We're looking into developing these machine learning models that predict for coronary heart disease, but we want to make these models more inclusive of ethnic minorities. So what we're currently working on is we're looking for data to kind of represent these ethnic minorities. We're contacting different labs and different advisors, and we're learning all these new things like machine learning and how to use all these genetic databases and a bunch of other things. Yeah.
Fantastic.
I think that's everything. Yeah.
I think that's everything. Next up, we have calling in from the Chan Zuckerberg Biohub in San Francisco, I believe, Axel and Mammal.
Hello. Yeah, okay, so I'm the team lead of the Mammal team, modeling areas for marine life. And the whole structure of this team is essentially building a rig for Rhea Storland. She's a PhD student here at UBC, and she's studying the physiology of marine mammals. Specifically the aorta of marine mammals, not, easy, sorry. So yeah, specifically the physiology of marine mammals. So marine mammals in general, they're interesting to study because part of like living in the ocean or living in the bodies of water that they do, they have to go for deep dives. So for example, here is a stellar sea lion on the right, it's the picture on the right. And so stellar sea lions, they live from like Vancouver, so like or actually down from California all the way around to Russia, just up the Pacific coast. And they can dive for up from like 8 to 20 minutes. And when you think about that, like when you hold your breath underwater, well, one, like that's not easy. And two, like it's much easier to hold your breath underwater when you're not moving as many muscles. Like if you could just stay still underwater, that's easiest. Where stellar sea lions, they're actively hunting for food. So the question is like, how can they essentially hold their breath underwater for such a long time, right? Next slide, please. A hypothesis is that Okay, so well, marine mammals have something called an enlarged ascending aorta. So you can see on the left picture there, the ascending aorta is that big tube right there. Oh, perfect. Okay, so marine mammals have a ascending aorta which blows up like a bulb. Okay, we know this. Like we can measure the ascending aorta of land mammals and sea mammals and say, okay. And we've known for a long time that marine mammals have a much larger ascending aorta than terrestrial animals. We don't know exactly why. And Ray's hypothesis is that it's beneficial for diving. The idea here being that when the mammal dives, the heart will essentially blow up the ascending aorta like a balloon. And then when it's called bradycardia, but when the heart slows down, like its heartbeat slows down, part of the blood pressure that keeps blood moving through your body is coming from the ascending aorta squeezing the blood out, like squeezing air out of a balloon. So yeah, that's like the hypothesis. So far she's studied specifically pressure within the aorta of like marine mammals as they've been inflating and deflating. And the goal here, and why the mammal team is being put in place, is to create a rig which makes a more dynamic test. Next slide, please. Perfect. Okay, so the whole idea with this is we want to test rig to sort of mimic a heart in a marine mammal. So you can see here on the right, that's kind of like the pressure over time curves. Essentially, what all this graph says, there's a lot of stuff going on. Essentially, all it says is that the heart's beating, and that's what the pressure in the heart looks like. So what we want to do is we want to measure the pressure in the aorta while beating blood into it, and then measure the volume in and out of the aorta. And from that, hopefully we can get a good idea of, okay, like what actual influence does the aortic bulb blowing up and deflating, what actual influence does that have on the blood pressure of the animal? So yeah, we aren't specifically looking for members right now, unfortunately. We're a fairly specific team, but in the future, if we do end up looking for more members, if we start expanding, I'll definitely reach out to Emma or the person responsible for grabbing people, and we'd love to have you. We're a really diverse team. Everyone from BMEG, Enchfizz, Chibi. We have a little bit of everything, but yeah, there you go.
Sweet, thank you, Axel. And I think that brings us to the end of our scheduled programming. And we look forward to hopefully reading your applications. Tell your friends there are lots of roles open, though I think we've also received a lot of applications so far. So spread the word. If you know anyone who might be interested, we're always looking for enthusiastic members who are eager to learn.
Thanks, Emma. Thanks, everyone.
Yeah, thanks for coming, everyone. Hopefully we'll read your application soon.
Yep.
Any closing remarks from other co-captains?
We've covered all the bases. Thanks very much for joining.
Thanks guys. Thanks for joining.